All right, so today we're taking a look at arc length. Yesterday we took a look at circumference, which if you remember is pretty much the perimeter of a circle, or the distance around a circle. Arc length is pretty much the same as circumference, however, it's a portion of the circumference. So let's take a look. The arc length of a circle is the ratio of the circumference of the circle determined by the central angle. So if we take a look here, the arc length, here let me use a different color so you guys can see a little bit better. The arc length is the distance around part of the circle that's formed based on an intercepted arc. So we have our central angle here, which is theta. Remember, theta is just a Greek letter to represent an angle. R is our radius. Remember, we need that to figure out the circumference, so we'll definitely need that for the arc length. And the arc length, as you can see, is just a portion of the circumference. So our formula for arc length, pretty much the same thing as circumference, is theta divided by 360. This is our ratio of the arc. So that's how much of the circumference times 2 pi r. So that's our circumference formula. So again, theta is our central angle divided by 360. So that's how much of the entire circle we're looking at times the circumference. All right, so let's take a look at calculating arc length. So for example 1, we're given that our central angle is 90 degrees and our radius is 16. So the first thing I'm going to do is identify both of those. Theta is equal to 90 degrees and the radius is equal to 16 meters. So to figure out what the arc length is, what I'm going to do is plug that in. So I have theta over 360 times 2 pi r. So what we're going to do is substitute this in. So we have the arc length is equal to 90 over 360 times 2 pi r, or 2 pi times 16. What I'm going to do first is calculate the exact arc length. So yesterday we talked about the exact versus the approximate. Remember, the exact arc length is going to have pi in your answer, whereas the approximate is your answer that's rounded. So after you plug it into a calculator, rounding to the nearest tenth or 100th. Based on what the directions are for this question, we're rounding to the nearest tenth. So we're looking for our approximate answer. But to find the exact, what we're going to do is simplify. So 90 over 360 is 1/4. I'm going to combine 2 times 16, which is 32 pi. And then 1/4 times 32 is 8. So my exact answer is going to be 8 pi meters. But again, we're asked to round to the nearest tenth. So I'm going to find my approximate arc length by plugging 8 pi into a calculator. So 8, I have to turn it on first. So we have 8 times pi gives us 25.13, so 25.1 meters. Okay, moving on to number 2. So number 2, just like number 1, we want to identify our central angle as well as our radius. Now in this case, we're looking at a major arc, meaning that it's greater than 180 degrees. So our central angle is actually 240 degrees. So central angle is 240. And our radius is 8 miles. Okay, so let's plug that into our arc length formula. Again, I'm going to find the exact arc length first. So I'm going to set this up as 240 over 360 times 2 pi times my radius, which is 8. And now off to the side, what I'm going to do is simplify 240 over 360. So 240 over 360. So let's think of numbers that would go into that. I believe 120 goes into both of these. So 240 divided by 120 is going to give us 2. And 360 divided by 120 is 3. So we can simplify 240 over 360 to 2/3. And we have 2 times 8, which is 16 pi. Now, anytime you multiply a fraction by a whole number, you multiply it to the numerator. So this is going to simplify. 2 times 16 is 32 over 3 pi miles. Now again, we're looking for our answer rounded to the nearest tenth. So we can plug that into a calculator. What I would do is type in 32 divided by 3, or divided by 3 first, and then multiply that by pi. And I get that my arc length is 33.5 miles. So my arc length is approximately 33.5 miles. Okay. All right, let's take a look at numbers 3 and 4. So just like what we did with circumference, for arc length for numbers 3 and 4, we're actually going to be working backwards, where you're given what the arc length is, and you're trying to find either the radius or the central angle. So let's start with number 3. So for number 3, we're given the central angle is 80 degrees. We're trying to find our radius. And you're given the arc length is 4 pi. So just like for circumference, start with your arc length formula. Arc length is equal to theta over 360 times 2 pi r. Now we can substitute in. Our arc length is 4 pi. Theta is 80, so 80 over 360 times 2 pi r. Now the first thing that I would do here is I would divide by 2 pi. The reason I'm allowed to do that is because 2 pi r is being multiplied to the 80 over 360. So we can cancel the 2 pi's. 4 pi divided by 2 pi is going to give us 2 is equal to 80 over 360 times r. Now, 2 different ways that you can solve for this. You can multiply by 360, then divide by 80, or you can multiply by the reciprocal, which is 360 over 80. I'm going to just keep it simple, multiply by the denominator, which will give me 720 is equal to 80 r. And I'm going to divide by 80 on both sides. And that gives me that my radius is 720 divided by 80 is 9. And then I didn't give you a unit here, so you could just put units. Okay, so that's how you solve for the radius when you're given a central angle and the arc length. All right, and for our last one today, we're going to be looking for the central angle. Okay, so again, start with your arc length formula and identify information that you're given. So you're given that the radius is 12. We're looking for theta. So let's start with our arc length formula. Arc length is equal to theta over 360. And the reason it's over 360 again is because 360 degrees is the entire circle times 2 pi r. All right, so let's substitute in some information that we know. So we know the arc length is 10 pi. We don't know theta. That's divided by 360. Then we have 2 pi times our radius, which we know our radius is 12. Okay, so let's simplify on the right side first. So we have 10 pi is equal to theta over 360 times 2 times 12 is 24 pi. What I'm going to do here is divide both sides by 24 pi. So similar to what we did in example number 3, how we divided by the 2 pi first. In this case, we have 12 pi because we know the radius. And now we can simplify that. The pi's will cancel. 10 over 24 will simplify to 5 over 12 is equal to theta over 360. And what you might notice is that we have a proportion here. So you could cross multiply, or since we know our variables in the numerator, all we actually need to do is multiply both sides by 360. And then 360 divided by 12. If we divide 360 by 12, we get 30. So 30 times 5 is 150. It's equal to theta. So theta is equal to 150 degrees. So that means our central angle for our arc length here of 10 pi would be 150 degrees. All right, so that is everything with arc length. Today for your daily assignment, or the problems on the weekly assignment, are problems 5 through 8. Please complete those. Remember, again, the weekly assignment will be collected at the end of the week and graded for completion out of 6 points. Please reach out if you have any questions. Have a great day.